All right, today we're continuing our discussion of antiderivatives and indefinite integrals, guys, but we are going to apply it to some trig functions as well. So as you guys may recall, guys, please be quiet. You three.
Is it the first way originally something? Your favorite?
An antiderivative is just the opposite of a derivative. Thank you. Showing. And so we've talked about polynomials. So we've talked about like x squared, x cubed. Now let's think about trig functions. So as you guys know, derivatives of trig functions are as follows. So the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x, right? And so that means when we integrate, we're going to have kind of the reverse. So that means that the integral of cosine x, so integral of cosine x dx, is going to be sine x plus c. We always have to have the plus c. An integral is really just a derivative in reverse. So if sine x gives us cosine x, then that means cosine x has to give us sine x.
Oh, so you're not doing the no minuses anymore? Like the cosine isn't equal to negative sine x anymore?
I understand. That's because the derivative of sine x is cosine x, and so therefore the integral of cosine x must be sine x. In the same way, the integral of negative sine x is going to be cosine x, right? Sorry, no integral on that one. The integral of negative sine x is going to be cosine x because we're really just flipping the derivative. So if the derivative of cosine is negative sine, then the derivative of negative sine is going to be cosine. And so this is going to give us the following relations. We know that the integral of sine x is actually going to be negative cosine x plus c. And the integral of cosine x is going to be positive sine x plus c. Right? And I'm getting these facts based on what I've just derived. So integral of cosine is positive sine. And if the integral of negative sine is positive cosine, then that means the integral of positive sine must be negative cosine. Make sense? I just got rid of the negative and flipped the sign. Any questions about that? So if you want an easy way to remember it, just remember that the signs are flipped. So sine will give you negative cosine, and cosine will give you sine, which is the opposite for derivatives, right? Just make sure you don't get them confused. Any questions?
Oh, so sine makes negative cosine, that's not. So flipped.
For integrals, they're flipped. Yes. Any questions? No. Memorized.
Just remember opposite from last year. So sine negative.
Okay, you guys can probably do 1A really quickly. And let me give you the rest of the formulas as well.
The homework we got last class is due this one.
Yeah.
Because I didn't do it. The homework got last class.
As you guys do 1A, I'm going to write down the rest of the formulas that you need to have memorized. And I'm going to try to connect them based on the derivative formulas that we've already reviewed.
Well, that's not even a you can say that about anything. Do we need to do the equation, or is that not how that's? Wait, no.
Huh?
4.
They're,
Just simplify.
I don't know why you rewrote it as an integral. When you're integrating it, you don't write the integral anymore, right?
So no dx and no integrals.
Yes.
And would it be plus c squared? It would be plus c plus c. Because c could be different things.
It's just going to be 1 plus c at the end.
Just all the numbers.
Because any c plus any other c is still going to be a c, right?
Mr. Matt, do you ever
Yep.
play COD when you were young?
Play what?
COD. Call of Duty.
No, I've never played any serious video games.
Really?
Yeah.
Were you allowed to? Or?
I had other interests.
Like what? Oh,
Soccer, math.
you played varsity?
No, I quit when I was 10.
You played Fortnite though?
As I said, no video games.
You have them.
I have not.
Ever?
No.
You play like poker?
A little bit with friends. Not seriously.
Or do you have a poker now?
Never professionally or anything. Or never with money, that's what I
The
meant.
last day of school, we should have class with
Are you act? No, Kira. Kira's not poker. Sometimes they kind of flip, do they not?
Okay, are you guys done? Are you guys done with 1A? Guys, are you guys done with 1A? Yes?
She wins the auto.
Yeah, the sign.
So, guys, here are the formulas for the other trig functions, okay? So as you guys know, the derivative of tan x is going to be secant squared, right? So that means the integral of secant squared is going to be tan x plus c. Very straightforward, right? All you're doing is just flipping all the derivative formulas that you've hopefully memorized. And then cotangent becomes negative cosecant squared. So that means cosecant squared will become negative cotangent for the integral.
Sick, that's cool.
So they all just, because an integral is really just a inverse derivative, right?
It's pretty easy.
Yeah.
And for the CSC one, I'm so glad calculus makes sense to me because I'm going to mechanical engineering. Yeah, I got business where I don't get to work.
Is calculus 1, 2, and 3?
So what's the derivative
It's
of
2x,
2x?
it's 2 and 3 hard.
Yeah, they get harder.
What about physics 1, 2, and 3? Oh, I know 1 will be that.
They're very different, right?
Are 2 and 3 hard?
I don't know what people normally consider 2, 3 physics. It's not as well defined as Calc 1, 2, 3.
Calc 1, 2, 3. Could you do Calc 3?
Yeah?
I think you get 100% class.
Yeah?
That's cool. Good for you.
I'm your teacher. I don't know how to respond to that.
Supposed to do that.
Well, he's not teaching Calc 3, so I didn't know. Do they have to like test you before you come in? Like they give you a test and be like, if you don't finish this, like
Or no, they just look at the resume.
So yeah, it's based on your degree.
you have to be super educated to educate other people.
Watch, I'm gonna
Not really.
and be accounting after dying in this class.
But you're not dying.
You're not dying.
Does he wait until he puts in my test score? I got an F.
You're doing great.
Okay, try to make sure you can do the whole first page. Let me write down some of the answers.
Was in bio, or yeah. With this Chamberlain. I can go to way better schools than those.
Me too. My freshman year,
I think it's 3.
I had 3, I think. I had a
Why do you sharpen your ears?
I was so close to B.
Why do you sharpen your ears? Like see where they're gonna put it. They do. There's still hair there. Oh, good. That's so cool. I think it's cool. Good, because where they would place the piercing. Like, so, same though. Which was here, let me. Timmy?
TY.
You're done.
I already turned.
Here you go. What are we doing now?
You're done with the worksheet? Thank you.
Okay, CSC caught. What is, oh, the minus 2x you have to do the other equation that we learned in power rule. Sure.
Sorry, what?
So for b, when you go to the negative or minus 2x, you have to use power rule.
Mm-hmm.
Wait, what?
Great.
What's up?
Wow, I have some typos here. I just noticed them. That's secant, right? Okay, should be nothing else. Okay.
You guys? You going to the championship?
Guys, focus on the worksheet, okay?
Today, if we went to Mars, yes.
The whole first page of 4.1b.
It's a 9C.
Yeah, A should be done in 5 seconds.
Where are you
So.
playing?
He doesn't have to beat them, but I'll come Saturday.
Where are you playing?
Mission or Santa Clara?
I'm not sure about
We play either
But you know? How do you know where I
Arizona or
live?
Hillsdale.
How do you know where I live?
Oh, yeah. I got it right.
Said you live in Santa Clara.
Look at that.
Good.
Have you ever seen no concept as well?
Seen what?
Have you ever seen me understand a concept?
I've seen you understand concepts, yes?
She's just asking weird questions. When I answer questions
I'm not sure how to do this.
Okay.
I don't think that's one of the memorized ones.
It's really weird. Seems like a typo.
Oh, wait, no, that's okay. So it's basically just like the same sex, right?
Dude, the answer's on the screen.
I took that from the textbook, but I'm thinking now that is not something that's very easy to do.
Is it a challenge problem?
I have no idea. Yeah, that's something you're not able to do at this point, so I don't know why it's on the textbook. Yeah, you can ignore that one.
Okay, got it. Thank you.
Yeah.
Usually just one second.
Are you done with 1A through D?
D? Yeah, I think I want to D with what letter?
The whole first page.
Oh.
Don't do question E though. That's a mistake.
What is this again?
I just took questions from the textbook, but I think they made a
What
typo.
is this?
Tonight, could you walk us through C?
It's not that hard. But what is that? What is that?
Just pretend like theta is x. It's just another variable.
Another variable.
What's x squared and that just goes away to 1?
No. You're trying to integrate x squared. So you raise the power.
Oh, 2x
Cubed, right?
X to the power 3?
1/3 x to the power 3.
Oh.
1/3 theta.
Yes. Okay, and then don't do 1e. There's something wrong there.
Cross that.
Don't do 1e. Yes.
Squared is minus sign goes in regular cosine, right?
What?
Negative sign goes to cosine.
Yes.
Regular cosine?
Negative sign goes to cosine.
Negative sign? Negative or negative?
The integral of negative sign is cosine. Okay, I'm gonna move on now. I will move on now. Let's talk about some basic differential equations. All right, so what is a differential equation? A differential equation is when you're given the derivative. So you're given f prime of x. Are you guys listening?
I'm listening.
You're given f prime of x, and you're also given an initial, what is called an initial condition. So an initial condition is basically something like f of 0. So you're given both the derivative and also the value of the function at a certain point. And what you're trying to find is the original function. Okay? And in this case, when we're looking for the original function, we don't want any more plus c's. So we want the exact function. And we can find the exact function based on the fact that we're given an initial condition. So I'll give an example. All right, so let's say we're given f prime of x equals x cubed, and f of 0 is equal to 1, something like that. All right, so we're told that the derivative of f is x cubed, and then we're given an initial condition, f of 0 equals 1. So the first thing that, guys, you said you guys were listening.
Sorry, I checked out for a second.
Now the first thing you want to do is find the general form of f of x. So you want to find f of x with some kind of plus c. And we know how to do that, right? F of x is going to equal the integral of f prime of x. And so all we need to do is integrate x cubed to find f of x. Right? Because we're given the derivative, and so to get the original function, we need to do kind of an inverse derivative, which is just an integral. And so f of x is going to be 1/4 x to the 4th plus c.
Okay, wait.
Agreed?
Explain it one time and I got it.
Because the integral of x cubed is 1/4 x to the 4th plus c.
Okay, question, Mr. Matt. If you give us a question, would it say, would it just be the top half? Or you just
Yes,
say
you
yes?
would only be given the derivative and an initial condition.
Perfect.
Okay?
Then what?
All right. Now we want to narrow down what exactly the function is, because we don't want a plus c anymore. In other words, we want to find what c is. And so in order to do that, we're going to need to plug in our initial condition. So we'll plug in our initial condition into the function. So f of 0 is 1/4 times 0 to the 4th plus c. And because f of 0 equals 1,
It's 0.
that tells us that c must equal 1, right? And so once we found c based on this initial condition, that helps us to narrow down what the function actually is. And so that's our final answer.
The condition could be different, right? Right.
Different?
So f of 0 could be different things.
Sure, it could have been something else as well, and that would have given us a different answer.
It says f of 1 is equal to negative.
That's fine too, yes. Any questions?
Could we try it?
Let me do another example now with a second derivative. Those are a little harder because we have some extra steps there. So let's say now that we're given a second derivative, and now we're looking for the original function. So we're given f double prime of x, and we're looking for f of x. So let's say my second derivative is equal to x. Okay? So when you have a second derivative, you actually need two initial conditions. So you're gonna need to know both the derivative at a certain point and also the integral at a certain point. So let's say the initial condition is f prime of 1 equals 2, and f of 0 equals 3. Something like that. Okay? So my first step is I'm going to try to find f prime of x. And so to do that, I'm going to integrate f double prime of x. So the first derivative is going to equal the integral of the second derivative. Make sense? In the end, yes, I'm going to do it twice. Right? Because if the derivative of the first derivative is the second derivative, then that means the integral of the second derivative is the first derivative, because they're just reverses, right? So I'm going to integrate x. So integral of x dx. And what is that equal to?
3.
The integral of x?
No, it's the
1 over 1 plus 1.
So 1/2 x squared, right? Plus c. Any questions?
That's what f prime of x equals.
Yes, so that's f prime of x. So we found the first derivative.
Now you have to plug that.
Now we have to find c. Okay?
How do you
Any questions there? So we found the first derivative, but we still have a plus c, and we want to narrow down what c is based on the initial condition that we're given, which is f prime of 1 equals 2. And so we are going to plug in x equals 1, so f prime of 1 equals 1/2 1 squared. Yes, no need to. Yes, 1/2 times 1 squared plus c equals 2, right? And so that's going to tell us what c is.
Oh,
C equals
you solve for c.
3/2. Any questions?
So that's the only way to solve for c is if you know what f
Yes,
prime
you need to have an initial condition in order to solve for c.
You have to have x of the next.
All right? So that narrows down exactly what f prime of x is. The first derivative equals 1/2 x squared plus c, which is 3/2. Okay? And then I'm going to do this whole process again to find the original function. Make sense? So with the second derivative, you have to do the process twice. All right? And so I'm going to integrate the first derivative to find the original function. And so f of x equals the integral of 1/2 x squared plus 3/2 dx. Make sense? To go to the original function, I have to do it reverse derivative, which is an integral.
You just have to take the derivative of those.
Yep, and I'll do that for you. It's going to be 1/6 x cubed plus 3/2 x, and then I have another plus c, right?
Do you have to solve for that again?
Yes, so I have to now solve for c based on the second initial condition, which is f of 0 equals 3. And so I plug in x equals 0, and that's going to be 0 plus c equals 3, right? So that tells me c equals 3. And therefore, my final function is 1/6 x cubed plus 3/2 x plus 3.
Yeah. It just makes sense.
After this unit, are we still gonna be doing stuff like?
No, integrals is the rest of the school.
Yeah, pretty much. All right, any questions there? So it's very important to keep track of which function you're looking at. So f, just keep track of your double primes, your single primes. Yeah.
Can you let me know if I got these?